Last time we went through the methods and separated the 7 examples that we were going to do by the type of solving that would be best for that problem. So we're going to start our examples with solve by factoring. So we're going to solve x squared minus 7x minus 60 equals 0. X squared minus 7x minus 60 equals 0 using the steps for solving by factoring. The first thing we need to do is get equal to 0 and in standard form. This one already is, so we're on to step 2, which is to factor. We want to check to see if there's a greatest common factor for these terms, and the only thing they have in common is a 1, so we don't worry about writing that. Then we want to see how many terms. There are 3 terms, so we're going to be factoring this by guess and check. So I'll set up my 2 parentheses. I know that first times first is x squared, so the only possibility will be x and x. Last times last is 60, so that could be 1 times 60, or 2 times 30, or 3 times 20, or 4 times 15, or 5 times 12, or 6 times 10. I know that I'm looking for my 2 terms to subtract, since this is negative, subtract to give me negative 7. So I would try different combinations. I have a feeling it's going to be the 12 and 5. When I check my outside and inside terms, 12 times x is 12x, and x times 5 is 5x. The difference between 12 and 5 is 7. I need that to be negative, so I need the 12x term to be negative and the 5x term to be positive, so that will be x minus 12, x plus 5. Once it's factored, we're going to use the zero product property and set each factor that contains a variable equal to 0 and solve. So I'll take each factor, so x minus 12, set it equal to 0, and x plus 5, set it equal to 0, and then solve for x, so I'll be adding 12, so x equals 12, or subtract 5, x equals negative 5. The next method that we used was the square root method. We chose 2 problems to solve by the square root method. The first step is to isolate the squared thing. So in our first problem, 9x squared equals 65, we will need to divide by 9, so we get x squared equals 625. And then to solve that, the next step is to square root both sides. So square root, and we get x squared equals, the square root of 625 is 25, so it will be plus or minus 25 over, oh, I forgot my over 9 here. And then the square root of 9 is 3, so it'll be plus or minus 25 over 3. In our second example, the squared thing is x plus 5 squared. It's already isolated, so we can go ahead and take the square root of both sides right away. And that gives me x plus 5 on the left side equals plus or minus, and then 18 is not a perfect square, but it breaks down into 6 times 3, and then 6 breaks down into 2 times 3, and then we have times that other 3 from before. We have a pair of 3's that's going to come out of the radical and turn into a 3, and then this 2 stays in the radical. So we have x plus 5 equals plus or minus 3 square roots of 2. And we still have to solve for x, so I'll subtract 5 from both sides. Remember that negative 5 goes in front of the plus or minus. So we'll end up with x equals negative 5 plus or minus 3 square roots of 2. Since those are not like terms,